Yes.
Okay.
So we're going to get started with the last lesson for your chapter 2 test. It is rational functions. We're going to be covering the domain, the vertical asymptotes, the horizontal asymptotes, and the oblique asymptotes. If you have no idea what an asymptote is, then that means you've never maybe talked about it, so I suggest you pay really good attention. The last 2-3 questions on your test are based on this section. Yes, sir.
Are they hard?
Are they hard? No, I don't think it is. Well, we'll see right now. I think it's an easy topic. I do, honestly. But you tell me before you leave. So the first thing for us to understand is a rational function is a function that is a quotient. So there's going to be some kind of fraction here. It's a quotient of 2 polynomials. We've already covered polynomials. Most of the time, you're able to factor something out from these polynomials. So your function, f of x, consists of p of x and q of x. It could be something like this. Now, the first thing that we're going to cover right now is something we've done before, which is find the domain. And if you remember, maybe you don't, we'll find out right now. In order to find the domain, we only cared about one part. So find the domain. And I don't have my other notebook with me where we covered it, but it was, I think, in the first or second section. I'm not too sure. But when we were looking for the domain, we only cared about the bottom part. Do you remember that? Where we had to set our denominator equal to 0. And then we were supposed to solve for x. Now, you're going to have to factor here. So if factoring is still not your strong point, then we're going to have to keep practicing little by little because we're going to use it a lot in this section. So the first problem, f of x equals 1 over x minus 3. Who's your denominator? X minus 3. What do we do with the x minus 3? We set it equal to 0. And then you solve for x. So I add 3. And I find out that x is equal to 3. Now, x is equal to 3. But is 3 a number that's allowed to be down here? No, because what happens if this is 3? It becomes 0. And if you have a 0 in the bottom, it becomes undefined. This basically is what your domain cannot be because it becomes a 0. For some of you, because if I say it doesn't go in. When I write it down and you write it down, maybe it stays there. This cannot be your domain because it becomes a 0. And you can't have a 0 because it is undefined. Now, remember that we would write them 2 different ways, set builder and interval notation. So set builder, SB, was all x such that, do you remember what we would do? X not equal to 3. We would write it down like this. Interval notation would be parentheses, negative infinity, comma 3, close parentheses, u, 3 positive infinity. So you're telling me your graph goes from a negative infinity to 3. It's not equal to 3 because of this. And it goes from 3 to positive infinity. Do you remember us doing this? Yes? Slightly, I hope, at least. Okay, that's good to know. So in a problem like that, who's your denominator? X. You said it, what? Equals 0. You solve for X, but is there anything you could do to solve for X? No. This is already your answer. You're done. So what is your domain in set builder? All X such that X not equal to 0. And your interval notation, parentheses, U, parentheses. Put the numbers in there and the symbols, the infinities and the zeros in the right place, please. Always going to be a negative infinity there, always going to be a positive infinity. And of course, this would be a 0. F of x equals x minus 3 over x squared plus x minus 2. So in this one, what type of denominator do you get? A trinomial. So what are you supposed to do with it? Factor my trinomial. We said equal to 0, make a table. My last numbers are -2. My middle number is a 1. Which are the only numbers that give you a 2 when you multiply? 1 and 2. But I need a -2. So who has to be negative?
The -2.
The -2. It's a 1. Let's see. Because why? I need a positive 1 when I add them. And if my 2 would have been negative, then they would have made it a -1. So you needed a positive 1. Your larger number always keeps the sign of your middle number. So my factors are x minus 1, x plus 2. Yes? Now, I'm going to rewrite it because in a little bit, we're going to be introduced into something else, just really quick. So this is the factors. When you do this, always make sure that nothing on top, your factor on top, which is x minus 3, does not match the bottom. Because if not, that's going to bring something else into it. Is there anything that's the same from your numerator and denominator? No. So in that case, because nothing is the same, then we set each factor equal to 0. So once again, I just rewrote it. It all factored out because I need to make sure that my numerator factor does not match any of my denominator factors. In a little bit, I'm going to tell you why. So we set them equal to 0, plus 1, plus 1. X is a positive 1. Minus 2, minus 2. X is a negative 2. So do the set builder and do the interval notation just to make sure we know that you know what you're doing. How many parts is the interval notation going to have? 3 parts. Very good. Because there is 2 answers. A negative infinity there and an infinity there. Put the numbers in the right place because it does make a difference. Go ahead and write it out. If you write down the wrong thing, it's okay. No problem. No worries. Is that what you got for set builder? Not equal to 1, not equal to -2. What's the first number I have to write down here? -2. And then here? -2, comma, 1, and then 1. Always in order from smallest to largest. So we're going all the way to -2. From -2, it's everything over to 1. And then from 1 to an infinity, not including -2, not including 1, because if I do, it makes the bottom a 0, and that's what you don't want. Are we okay there? Yes, perfect, awesome. Questions?
So we don't want a 0?
We don't want a 0 in the denominator of a fraction because it becomes undefined. It becomes undefined. So one more from this section, just a different, they look differently. Not that the answers, it's still the same process. Work on that one, please. So this is just reviewing how to find your domain. Reviewing how to find your domain. Problem number 1 is going to come from example number 1, and this is the last one for the domain. See if there's anything you can factor in the bottom. Factor it out. Set your factors equal to 0. What would you do in a problem like this? Just what? Add 6, fine. And I get 2x equals to 6. X is a 3. Now, maybe some of you factored out a 2. And if you did, you still get the same answer. It's 2 equal to 0, impossible. X minus 3 is equal to 0, you still get a what? A 3. Whichever approach, whichever step you took to solve for x, you still get the same answer. So, set builder, interval notation, all x such that x is not equal to a 3. Negative infinity to 3, union 3 to infinity. So are we comfortable with the domain part? Something we've covered already. Yes? Now the next thing we're going to go into are vertical asymptotes. Vertical asymptotes, you work them out the same way, except the answer these here are your vertical asymptotes. So just giving you a heads up. This is your vertical asymptote. This is your vertical asymptote. These are your vertical asymptotes. But we're going to do some right now. Now, does anybody know what a vertical asymptote is?
That
Those things. But what does it do in a graph?
crosses
It's
the
the
line or something.
line that the function approaches when the direction is.
Very good. A vertical or horizontal asymptote, it's something that you get really close to it, you never touch it, and you never cross it. I used to tell my high school students, it's like an electric fence. You come close to it, but hopefully you're smart enough not to touch it or try to jump it, because if you do, maybe you won't die, but you're not going to be all there for a couple of minutes.
Would it be parallel?
Mm,
Like almost parallel to it?
no, not necessarily. Not necessarily. So let's talk about these vertical asymptotes. asymptotes. Vertical asymptote. So we do the same thing. Set the denominator. Have a nice trip. Bye. Equal to 0. Solve for x the way we were doing for the domain. So it's not like we're doing something new. It's just the way we write it, it's going to represent something different. So once again, this is your equation. But please notice here what it says. We need to make sure that P of x and Q of x don't have a common factor. If they do, it is called a hole. There's a hole in the graph. Okay. So vertical asymptotes, example number 2. Find the VA. VA stands for vertical asymptote. Here's our first problem. F of x equals 2x minus 11. And then I'll take a little pause because I think I'm talking and writing too fast. So sorry. So this is the first problem. If you know what you're doing, look at your denominator. Can you factor something out? And if you could factor it, already factor it into both terms, whatever 2 terms you get. And these problems, once again, it says make sure that P of x and Q of x, your numerator and your denominator, don't have a factor in common. So in this section, you have to factor your numerator, if possible, also. If possible. So when I see 2x minus 11, is there anything that could be factored out from there? No. So then you're okay. You just worry about factoring out your denominator. So this is going to stay like that over something. I don't know what that something is until I factor this guy out. Numbers that multiply to 8 are 1 and 8 and 2 and 4. So who has to be negative? The smaller or the bigger? The smaller, right? So this gives me a positive 7. This gives me a positive 2. So these are my factors. X minus 2, x plus 4. X minus 2, x plus 4. I rewrote it just to double, triple check. Is there anything common in your numerator and denominator? No. Perfect. So set your denominator equal to 0. Solve for x. Make sure that nothing's in common. Nothing was in common. So then I have to do this last part and solve for x. So I have x minus 2 is equal to 0. X plus 4 is equal to 0. So x is 2 and x is a what? Negative 4. Now earlier, this would help us to find the what? Domain. Right now, we're looking for the vertical asymptote. Your vertical asymptotes are at x equals 2 and x equals negative 4. It has to say x equals and x equals. If you don't type them in as x equals and x equals, the answer will be wrong. So just so you could imagine what's going on, not that we're going to be graphing right now, but basically is you have a graph Yes? At a 1, 2, 3, 4, -4, there's this little invisible line that you cannot see at x equals -4 and x equals +2. That's going to it's going to break the graph into 1, 2, 3 parts. So I am going to graph this really quick. And of course, parentheses, 2x minus 11 divided by x squared plus 2x minus 8. So if you look at this graph, you see how it splits it into 3 graphs? So you have a part of your graph coming in like this. It gets close to that -4, but it's never going to touch it. You have something between here, never going to touch it, and then you have something down here, and it keeps going this way. That one keeps going this way. Now, if I were to ask you, write down your domain for this problem, based on what we learned in the first example, in interval notation, you would tell me it comes in from -infinity to who?
-4.
-4, union, -4 to 2, union, 2 to infinity. So look at the graph that I kind of sketch here. Is it coming in from -infinity and stopping at a -4? Yes. Is this middle part between a -4 and a 2? Yes. Does this part of the graph go from a 2 to a positive infinity? Yes. So the vertical isotopes are the ones that set the limits to that domain. So once again, asymptotes are vertical lines. Vertical asymptotes are vertical lines that tell you your graph cannot go past this line, your graph cannot go past this line, your graph cannot go past this line. It just basically sets a limit. You cannot cross it. An electric fence, you get close, do not touch, do not cross it. If you cross it, you're wrong. If you touch it, you're dead. Yes?
So what's the domain again for this one?
-infinity to a -4. So this part of the graph goes from -infinity to a -4. This part of the graph goes from a -4 to 2. It's between those two, and this one starts at a -2 off to positive
Oh, that's
infinity.
also the domain. Okay.
This is your domain. This is your vertical isotopes, and your domain go hand in hand. This tells you basically the numbers that cannot be part of your domain. Those are your vertical isotopes. Remember, if you have a graphing calculator, if I go here, what does it say at a +2? Error. You can't have anything there. What does it say at a -4? So those are your asymptotes right there. Those are it. All right, let's do 1, 2, 3 more. H of x equals x squared minus 4x over x cubed minus x. So when you look at this at the top and bottom, can I factor something on top? Yes. Can I factor something in the bottom? Yes. What can we factor out on top?
Difference of square?
It's not a difference of square because this one has an x. So Elsona says we could factor out an x, and that is correct. When I take out an x from here, what's left over? X. When I take out the x from there, it's a -4. So are we okay there? Yes? Divide by, what can we factor out here? An x. If I factor out an x, what's left over? X squared minus 1. Now, Nick, what is this?
Difference of square.
A difference of square. Your denominator is a difference of squares. So the top, again, we rewrite it as that. The bottom becomes x plus 1, x minus 1. A difference of squares is when you have a square, a minus, and a number you could take the square root of, like a 1, a 4, 9, a 16, a 25, 36. All those numbers you can take the square root of. So the square root of this one is 1 and 1. 1 positive, 1 negative. Are we good? So the instruction says factor. Make sure that your P of X and your Q of X don't have anything in common. Do they have anything in common?
The first X.
X.
This is what they have in common. It says if they have something in common, that is a who? A whole. It is not part of your vertical asymptotes. So where is the whole going to be at? X equals to 0. So if there is something in common in your numerator and denominator, that is a whole. It is not part of your vertical asymptote. It is something that you push aside. It's not going to be part of it. So what do I have left over in the bottom? X plus 1 equals to 0. X minus 1 is equal to 0. So X is a negative 1, and X is a positive 1. So who's your vertical asymptote? X equals negative 1, and X equals a positive 1. We have a whole at X equals to 0 because this is what they have in common. Yes? Okay. If we had to sketch a graph at a positive 1 and at a negative 1, you're going to have what? These little lines. Because of this whole, when you graph, you know how in the other one we had something in the middle? At this part, there's a hole in the graph. There's a hole. If you could zoom in, which we can't on the calculator because it's not that perfect and beautiful. Let me just try to graph this.
So that would be like an open circle?
Yes, it's an open circle. It's like a hole in the graph. That's what it is. Make sure you're not walking on that line because you're going to fall through. So once again, your graph comes from here. There's a part of the graph up there. There's a part of the graph up there. Now, when you go to your table, because there's a hole and there's not a point there, it's still going to say what? Error. But not because it says error does it mean it's going to be part of your vertical asymptote. So this is why you need to be good at factoring both your numerator and denominator. So basically, as you factor top, factor the bottom. Is there anything in common? If there is, you write it, put it aside. If there isn't, you just set them equal to 0, and those are your vertical asymptotes. Try this one. G of x, x minus 2 over x cubed minus 5x. It's a little bit different. We're halfway done with the lesson, halfway done. Once we finish this problem. So ask yourself, can I factor something on top? No, you just rewrite it. Can I factor something in the bottom? Yes, factor it out. Set your factors equal to 0. Go as far as you can. No need for you to. And in example 4, right now, we're going to use synthetic division, which we talked about it in the previous lesson. just remembered something. Is this what you guys got? Yes? Is there anything in the comment on top and bottom? No. This x belongs to that minus 2. You cannot say, oh, they're the same. It's not the same as this type of problem. So there's nothing in common. So I have an x equals to 0 and an x squared minus 5 is equal to 0. Now this is already solved for x. Yes? What do I have to do over here to solve for x? First step is what? It's not a difference of square because I can't take the square root of 5.
Add 5.
Add 5 is a good step. X squared equals a positive 5. Square root on both sides. And anytime we have a square root, we said our answers would have to be what and what?
Plus or minus.
Plus or minus. Thank you, sir. Plus or minus the square root of 5. So who are my vertical isomtopes? X equals 0. X equals the square root of 5. And x equals the negative square root of 5. So depending on your denominator, sometimes this is a situation. Sometimes it's just perfect squares. Sometimes it's something we could take this, find the factors of. It just depends.
On the test, are you going to take x equals plus or minus root of 5, or do you need to write both of them?
No, this would be fine with me. I think on your assignment, if this is the case, you have to write them out separately. One positive, one negative. So this is why I wrote it like that. But on your test, I would not take off for that. Any questions? So next thing is we're going to go into horizontal asymptotes. And I'm going to turn the page just so we can have the notes on top of that section because there's 3 rules to it. 3 rules to horizontal. So for the horizontal asymptotes, you have to look at the degree. What is a degree? The largest exponent of the top, the largest exponent of the bottom. You don't look at all of them, you look at the biggest one. So they're all exponents, but the degree would be the largest one. So we look at your degree of your numerator, and if it is less than the degree of the denominator, then your horizontal asymptote is y equals to 0. If the degree of your numerator is equal to the degree of your denominator, then your answer is going to be your leading coefficient over your leading coefficient. I like to just call it LC over LC, but that's what LC stands for, leading coefficient. Leading coefficient is the number in front of your degree. And we're going to do one of each so you can see. If your degree of your numerator is greater than the degree of your denominator, there is no horizontal asymptote. There is an oblique asymptote. And that is the last 2 things we're talking about, horizontal and oblique. So if you don't have a horizontal, then you have an oblique. And to find the oblique, you have to do synthetic division. Are we okay? Yes? Everybody with me? Example number 3, find the HA, horizontal isotope. This one's a lot easier than the other one because you don't have to factor anything. You're just looking at it. 2x squared plus 1 over x squared. So you're looking for the degree. Let's make this 2 into a 3. Because then we're going to get confused. I want to know exactly who you're talking about. So make this 3x squared plus 1, x squared. Now, who's the degree of the top? That square, that 2. Who's the degree here? 2. So when I look at the degree of the numerator and the degree of the denominator, is it less, equal, or greater? So your degree of your numerator is equal to the degree of the denominator. Yes? So the rule says if your degrees are equal, your answer is going to be y equals leading coefficient over leading coefficient. Well, who's your leading coefficient here? 3. Who's your leading coefficient down there? It's a 1. So I have 3 over 1, which is just 3. That is your horizontal asymptote. So if you would be graphing this at 1, 2, 3, there would be a dotted line right there. And that gives you more restrictions for your graph, if that were the case. Now let's look at B. F of x equals 2 over x squared plus 4. What's your degree in your denominator, in your numerator?
4.
Is there?
7.
Why is it 0? Because there is no what? X. Your degrees belong to variables. And this is the reason I threw this problem in there. Because sometimes, since there's no x, there is no degree. It is 0. But what's your degree in the bottom? 2. So my numerator is less than my denominator because this was 0 and that is 2. Do we agree? Yes? So anytime that the numerator is less than the denominator, well, who's your horizontal asymptote? Y equals 0. That's the automatic answer. Y is equal to 0. That's it. Last problem, f of x equals 2x squared minus 3x minus 1 over x minus 2. So in this problem, my degree of my numerator is 2, and this one is a 1. So the numerator is greater than the denominator because this is a 2 and this is a 1. So for this problem, we have no horizontal asymptote, but we have something called the oblique asymptote. Now, for the oblique asymptotes, it means it's going to be a slanted line. It won't be a horizontal or a vertical line. It's going to be a slanted line, which takes us to example number 4. Find the oblique. Sometimes they use the word slant. That's the way they taught it to me, but it means the same thing, asymptote. And we're going to take same problem from C to find the oblique asymptote. So the problem is f of x equals 2x squared minus 3x minus 1 divided by x minus 2. Now, I need for you to understand, this is a division problem. Division problems we covered on Monday. So if I had to divide this, you could use long division if you want to, but synthetic is a lot easier. Yes? If I had to divide this, what would be the number outside here?
+2.
A positive 2. Very good. Who are going to be my coefficients, my constants, my numbers?
2,
2,
-3.
negative 3, and a negative 1. The rule is to always bring down the first number. So that's a 2. What's 2 times 2? 4. Negative 3 plus 4 is a 1. 2 times 1 is a 2, and this is a 1. We learned this was remainder, we learned this was constant, and we learned this is your x. Yes? When it comes to the oblique asymptote, you don't care about the remainder. This is what you care about. My oblique asymptote is y equals 2x plus 1. This is what that would be. 2x plus 1. Now, we're not graphing it, but if you had to, what would be your vertical asymptote? If you had this as your denominator, x equals what? 2. At a 2, you would have your vertical asymptote. Do you know how to graph this by using your y-intercept and your slope? Your graph starts at your y-intercept. My slope is what? Up 2, 1 to the right, up 2, 1 to the right. So we have your so this sets your limits. Your graph would be somewhere here and somewhere there. So these are the 2 lines that you approach, but you don't want to touch. Are we okay with that? For the most part, do you feel okay finding all that right there? Yes? Alrighty. Let me just check something real quick.